This solar panel is composed of 108 solar cells. They are arranged in rows of 9 and soldered in a serial configuration. There are 3 groups of 36 cells that are wired in a parallel configuration. The maximum output of this entire panel is 18 volts. 18 volts is the standard output to be able to charge a battery, considering most batteries are 12 volts and you cannot charge a battery adequately on 12 volts. You could take every single solar cell and wire them in a series, which would give you a lot more than 18 volts, probably 54 volts. But that would be too much voltage for your battery, and you definitely fry your battery. Having the separate group of 36 cells per 3 groups will increase your amperage, but your voltage will remain the same at 18 volts. So here we have the breakdown of evergreen solar cells. The typical capacity for these cells are 0.5 volts per cell and 175 watts per cell. In a 36 cell group you can get about 3.5 amps. These solar cells are very fragile and you need to handle them delicately in order to not break them. They're actually very brittle. They snap very readily, and you will lose a couple as you're doing this project. And here are the evergreen solar cells. You have the pretty blue side is the negative side of the cell, and the gray side is actually the positive side of the cell. They're commonly available on the internet, especially eBay. Right now they're going for a pretty cheap price. The front side of the solar cell is the blue side, and it's also the negative side of the solar cell. On the front of the cell, you have your cross wires, and if you bought pre-tab cells, you have your 2 tab wires soldered to the front. It's important when buying these solar cells to not buy untabbed solar cells because it's very difficult to solder the wire on the front of the cell. On the back side of the solar cell, you have 3 areas, 3 white squares that are available for soldering your tab wires. And how these are fit together is you want to put the good side or the blue side down on the table, and you want to solder the wires coming from the front of the cell, which are actually your negative leads, to the back of the cell, which is the positive side of the cell. And how you do that is you lay them out on the table, and you take the tab wires and place them over the white squares, and these will be your 3 solder points for attaching the tab wires. In order to get adequate spacing of the solar cells, so you'll be able to fit them on the glass panel later, you need to make a jig. This is the wooden jig that we use to properly line up the solar panels. All it is a piece of wood, and we've spaced out the cells using these 1/4-inch tile spacers. They're just made of rubber. You can find them at any hardware store in the country. And we've come up with a template for each of the solar cells. You do not want to use the actual solar cells. You know, it doesn't end very well with a stapler. So you want to make sure that your jig is square. So you always want to have a perfectly straight line in order to line up the piece of cardboard. So you simply put your cardboard jig down, and when you want to align your tile spacers on the corners of your cardboard jig, and you secure each of these tile spacers with a heavy-duty stapler. You want to be as precise as possible when doing this, because if you solder the joints uneven, you will not be able to fit them properly on your finished product. Lay 9 panels, blue side down, in the jig. The negative leads from the front of the panels should be arranged so that they are on top of the white squares on the back of the panel. The white squares are the only places you can solder the wire on the back of the panel. Use weights to weigh down the tab wires from the front of the cells over the white squares. We have used glass weights instead of metal because the soldering iron acts as an electromagnet and will pull metal objects toward the iron. The type of solder to use is a 60% tin, 40% lead rosin core solder. Do not use lead-free solder because you will have to heat it up too much and you may burn the back of the cell. To ensure a good connection, bring the tip of the soldering iron and the solder to the tab wire. Do not heat up the solder on the tip of the iron. This will cause the solder to become cool and you will not get a good connection. Any faulty connections will cause the panel to not have maximum output. Overheating the connection will cause the white square to burn away and you will not be able to solder the cells in place. If this happens, you will have to remove the cell and replace it with another cell. Cut 2 tab wires for the last solar cell and solder them in place. After all the panels